Today we're going to be talking about 2-1 characteristics of functions. The first characteristic we are going to look at is symmetry and classification. Symmetry, remember, is the reflection of a graph on a dividing line where the shape of the graph is exactly the same. This is also known as the mirror image. In other words, we are looking at how can I fold my piece of paper to where the two graphs or two halves of the graph match up. Classification, we are going to do only on graphs, and it is based on a function's symmetry. These two are tied together. So we have three types of symmetry we're going to look at. We are going to look at x-axis symmetry. Remember, your x-axis is your horizontal axis. So if I want to take this triangle and flip it across the x-axis, that point would end up down here. And I would end up with this. This graph is symmetric about the x-axis. The classification for x-axis symmetry is neither. It is neither even nor odd, which are your two classifications we're looking for. Y-axis, as you remember, will be your vertical axis. So if I want to reflect this over the y-axis, those 2 points would end up right there. So my graph would look like that. If it has y-axis symmetry, it is an even function. The last one I'm going to talk about is symmetry about the origin, where the first two were reflectional symmetry. Origin symmetry is actually rotational. So I'm going to take this triangle and I'm going to rotate it 180 degrees. So the point 2, 3 ends up at -2, -3. 4, 0 ends up at -4, 0. And my graph would look like that. This classification is odd. And finally, if it does not have one of these three, you can say it has no symmetry. And no symmetry would also get a classification of neither. Before I go on to example 1, there is one note I want to talk about. If a function has all three symmetries, x-axis, y-axis, and symmetry about the origin, we are going to classify it as both even and odd. There are not many graphs that have this classification, but there are a couple, and one we're going to look at in just a second. So if I look at example 1, what I'm asking myself is how can I fold this paper in half so that the two sides match up? And in this case, I could fold it on the x-axis. So if I folded it on this red line I just drew, both the blue parts would be lying on top of each other. Therefore, this graph has x-axis symmetry, which has a classification of neither. The next one, there is no possible way to fold this in half or turn it 180 degrees so that the two parts will match up exactly. So this is not symmetric. So for symmetry, we'll write none. It still has a classification, and it is neither. See? Here, I can fold it in half on the y-axis, that red line I just drew. If I fold it in half on that line, both of those graphs match up. Therefore, it has y-axis symmetry, which means it is an even function. Finally, D, if I take this part of the graph, I can't fold it to match up with the other part, but I can turn it 180 degrees. Therefore, it is symmetric about the origin, which means it is an odd function. E, if I look at this, it has x-axis symmetry. I could fold it in half on that line and it match. But it also has y-axis symmetry. You can fold it in half on that line and it would match. And finally, it also has symmetry about the origin. So I could turn the whole thing 180 degrees and it would match up exactly. So this is the case that has all three. It has x-axis, y-axis, and origin. Which means for classification, it is both even and odd. Finally, on F, there is no way to fold this or turn this in half to match up, so it has no symmetry, and the classification is neither. So characteristic 2 that we're going to talk about is where is a graph increasing, decreasing, and constant. To do this, we need to identify the critical points. So remember, a critical point is a point of a function where the graph changes direction. To find where a function is increasing or decreasing or constant, we're going to find, step 1 is you're going to find your critical points. These are your minimum points, maximum points, or vertical asymptotes. Remember, a vertical asymptote is a line that a graph will get ever close to but never ever touch. Usually on our graphs, it's seen as a red dotted line. So to find the increasing, decreasing, or constant, we need to look at the graph from left to right, just as we are reading a book. So for increasing, the y values will be going up. Decreasing, your y values are going down. And for constant, they are staying the same. The main thing we need to look at is I only care about the x value where this is happening. I don't care how far up or how far down it goes on the y value. I am only looking at the x value when I write in interval notation, or when I write increasing, decreasing, or constant. And I'm going to write this in interval notation. We are going to make sure to only use the x values and parentheses. We are going to use absolutely no brackets. This is the only time in interval notation when we will not use them. Okay, absolutely no brackets in when we're talking about increasing, decreasing, and constant. So if you were to trace the graph, what you're looking for is, as I draw it left to right, is my pencil moving up? Is my pencil moving down? Or is it going straight? That'll tell you whether it's increasing, decreasing, or constant. So let's look at a couple examples. So looking at 2a, first thing I need to do is I need to go ahead and find my critical points. That is the beginning or any min or max that is in the graph. These are all things where the graph changes direction. So these are important values for me. So I'm going to go ahead and write down the coordinates. From here, I'm going to just start tracing my graph. I'm going to start at the beginning and see what happens. So how I connect the first 2 points is I drew a line up. Therefore, it is increasing. Now, I only care about the x values. So my x values where I am increasing are from -6 to -4. Now let's see what's my graph going to do. I am tracing my line down. That is a decrease. And again, we're only looking at the x values, -4 to 0. Now it turns around, and now as I trace it, it's going back up. So that is an increase from 0 to 2, but I already have an increase. So remember from a couple days ago, when I connect more than one interval, I need to put a U in between them. So I'm going to union that with my 0 to 2. Coming back to my graph, still tracing it, drawing from right to left, my graph goes down. That happens 2 to 4. Again, I already have an interval there, so I will put a union. Now my graph goes straight across. That's a constant from 4 to 7. And finally, the last part of my graph is going up, and that happens from 7 to 9. And put another union there. So if I look at B, I'm going to treat it the same way. I am going to find my critical points. It's right here and right there. So this is my point 0, 0. This is the point 2, -4. Notice this graph doesn't have a specific starting point nor ending point. So if you look, these arrows mean they go forever. So since it doesn't have a starting or a stopping point, my two end things are going to have to involve infinity. So as I trace my graph, even though the arrow is pointing down, if I'm drawing my graph from left to right, I am actually going up. Therefore, this is an increase. And it's going to increase from negative infinity, since there was no starting point, to 0. Now my graph turns around and it comes on back down. That is from 0 to 2. At that point in time, it turns around again and goes back up. That, so I need to put union, is from 2, and it doesn't have an ending point. It keeps going and going and going, which is infinity. If there is ever a blank, whether it's increasing, decreasing, or constant, that you do not have anything for, you need to put none in the blank. If you don't, I will mark it wrong because I'll think you just didn't know how to do that part. So if there is not an interval where that takes place, put none. Finally, on this example, let's look at C. C is what we call a piecewise function, remember, from Math 1. We will be covering these more in depth in just a couple lessons. So I'm going to start at the beginning, looking left to right. This is just staying constant. Okay, and this is the point, -4, -3. Okay, it is constant from negative infinity to -4. Now my graph jumps. That's okay. But how can I draw that? I am going up. So that's an increase. And my x values at that point are -4 to 3. Finally, my graph jumps again. And it's going down. So that is a decrease from 3 to infinity. And remember, it goes down forever, but it's a positive infinity because my x values are getting larger. The last thing we're going to look at is domain and range. So domain and range is something that we have done pretty much in every math class from Math 1 on, and we will continue to do it in next semester's math class. This is a concept that we'll pretty much hit every single unit that we do all year long. So remember, your domain is your set of all your x values. In which a function is defined, and we are going to look left to right. Your range is your set of all y values. And for that, you are going to look bottom to top. If you have a hard time remembering what is domain and which one is range, think they're in alphabetical order. X comes before Y, D comes before R. So if I look at example 3A, what I'm asking myself, is there a starting point? Is there a stopping point? Are there any holes? So as I look left to right, does it have a starting point? No. Does it have a stopping point? No. Are there any holes? No. If they are all no's, your domain is all real numbers, which is negative infinity to infinity. Next, let's look at the range. So the range is bottom to top. Here, there is a clear starting point. There is nothing below this green line. So my graph starts at -2. And -2 has a point there, so it is going to be a bracket. Now it goes on forever and ever and ever as it goes up. That's what those arrows mean. So it doesn't have a stopping point, and therefore it goes to infinity. When I look at B, yes, left to right, there is a distinct starting point. It starts here, doesn't go beyond that. So it starts at -4. It is an open circle, therefore it is not included, so it gets a parenthesis. There's no more holes as I look left to right, and it goes on forever, so that's infinity. Looking bottom to top, it starts at -2 and goes up forever. Again, -2 is not included, so it is a parenthesis. Moving on to C. There's no starting point, there's no stopping point, there's no holes as I look left to right. So that is -infinity to infinity. As you know, the domain of all quadratic functions is all real numbers. Next, I'm going to look at my range, bottom to top. So my bottom goes forever, but my top stops here. So that is going to be -infinity to 3. And that's going to get a bracket because that is included. There is a point at 3. Okay, looking at my x values, it's from -4 to 2. -4 is included. 2 is not because it's an open circle. Looking at my y values, it's -3 to 3. This time my -3 is not included, but my 3, not 2, sorry. 3 is. And finally, on E, what you will notice is I have a hole. This hole is going to break up my domain. I'm going to have this set for the domain and this set for the domain, but I can't have one. So that is going to be -infinity to 1, union 1 to infinity. It can be anything but 1. For my range, it starts at -4 and goes up. But -4 is a hole, so it is a parenthesis. Final thing we're going to do is we are going to take and we're going to combine everything that we have just done into what the assignment's going to look like. So looking at example 4a, let's start with domain and range. If you look left to right, there's no holes, no starting points, no stopping points. Therefore, it is -infinity to infinity. My range, it goes on forever in a negative direction, but it stops at 3. And there are 2 points at 3, so it is going to be a bracket. Next, if we go to increasing, we look for our critical points. So I have one here, and one here. So I break that up into parts. It is increasing there. So that is -infinity to -2. It then switches over and it decreases. So that is -2 to 0. Then flips back up, so it is increasing. So that is 0 to 2. And goes down, so that is decreasing. So that's 2 to infinity. And it is constant. It is not constant anywhere, so we will put none. Symmetry, if I fold it in half on the y-axis, it matches up. So that means it is y-axis symmetry, which therefore means it is even. B, we have this function. Notice both for the domain and range, they go on forever in opposite directions. There's no holes, there's no starting points, there's no ending points. So the domain and range of this function, which resembles a cubic function, would be negative infinity to infinity. Finding my critical points, I have one here and one here. So starting at the beginning, this is an increase. So that is negative infinity to -1. In the middle, that's a decrease. That's -1 to 1. And at the end, it goes back to increasing. So that is 1 to infinity. And again, this constant is none. Symmetry. I can't fold it in half on the x nor the y-axis and get them to match up exactly, but I can take it and turn the top half 180 degrees. Therefore, it's symmetric about the origin, which means this is an odd function. Last one. You'll notice I have a hole. So when I take my domain, I need to keep that in consideration. So my domain is going to be negative infinity to 0. That's where the hole is. And then it's 0, but the graph ends at 4. For my range, it starts down at -3. And it goes on forever. Now, even though there is a hole at -1, there are many other points on this graph where -1 exists. So there really isn't a hole in our range because there are some range values that have -1 as their y value. So next we're going to look at increasing, decreasing, and constant. As I go from left to right, my graph is decreasing. So it is going to be a decrease from negative infinity to -1. And now it stays constant. And that is from... So it is constant from -1 to 2. And then if I go back to the graph, it decreases again from left to right. And that happens from 2 to 4. Now notice since we had a hole at 0, -1, but I didn't take that into consideration when I do increasing, decreasing, constant, unless it changes the direction of the graph. Because at this point, we're saying overall, what's the overall trend? What is the line doing? It is increasing or it's constant, even though it missed that part. So here, the graph never increases, so we put none. The last thing we need to do is classification, the symmetry. It has no symmetry. There is no way I can graph that, fold it, turn it to match up, and therefore the classification is neither. If you have any questions on this section, please feel free to reach out to me and ask, and I will talk to you guys tomorrow.